Hello and welcome back to digital signal processing. In this video, I will show a method to design FIR and IIR filters using filterDesigner tool in Matlab. So to open GUI, type filterDesigner in command window. Press enter. Now, you can see several types and options available in this interface. So the first option is frequency response. And in this, we can select different types of filters we want to design, such as low pass, high pass, band stop, and differentiator. There are other specific types that are included. Suppose click on low pass, you can see there are other specific types. So these are all low pass filters with different characteristics. So we have razor cosine, half band low pass, iniquitous, inverse sync low pass. And similarly, we also have the other types in high pass and then in differentiator too. So the first option is the frequency response type. The next option is the design method. So two options are included. One is IIR and other one is FIR. Select one of them. And you can see there are several other options in FIR and IIR. So these are prototype filters. So in FIR, we have equilibrium, least squares, window, complex equilibrium, maximally flat, and so on. Similarly, in IIR, we have butterworth, shim sharp, maximally flat, and so on. So the second one is called the design method. Next comes the filter order. So we have to choose the order of the filter. We can design filter with specific order or with a minimum order. If you want to design filter with a specific order, just give the order of the filter and we have to give it in as a whole number. And if you want to design the filter with minimum order, select minimum order. Next option we get is called the density factor. This is by default, it is 20 and keep as it is. The other two options are frequency specifications and magnitude specifications. So frequency specifications, generally frequency is expressed in hertz. So we can see hertz, kilohertz, megahertz, and gigahertz. There is another option called normalize 0 to 1. We have to choose this option if you want to express frequency in radians or if you are going to use discrete frequencies. And also, if you don't have any idea about the sampling frequency. So if you don't have any idea about the sampling frequency, click on normalize 0 to 1. Then, obviously, this is disabled. Now, it can give the passband frequency and stop band frequency. And because the range is from 0 to 1, here the pass and stop band also must be between 0 and 1. And if you are aware of the sampling frequency, then you can select hertz, kilohertz, and megahertz and give the sampling frequency you want to take. Suppose if I want to consider 10 as a sampling frequency, then type 10 there. Now, then you have to give the passband frequency and stop band frequency. So when we have the sampling frequency, we have to follow the Nyquist criteria. That is, the sampling frequency should be 2 times of the bandwidth. So here the values that are allowed for pass and stop to satisfy the Nyquist criteria is because it is 10, it can be 5. Maximum value for pass and stop band can be 5. So this is this frequency specification. Next comes the magnitude specification. Generally, magnitude is expressed in decibels. And then we have attenuation, pass, and stop. By default, their values are 1 and 80. Keep them as it is. And then the next is the response type. So if we want to, next is a response type. So we already have seen what is a response type. Now, by using these types and options, we can design a filter. So first thing is we have to know which type of response you want for the filter design. Low pass, high pass band, stop, or differentiator. Next, which design method we are going to adopt, that is FIR and IIR. And in IIR, we have several other options, so you can select one of them. And then the order of the filter is important. If you don't know the order, go with the minimum order. And density factor is 20, keep by default, keep as it is. And give the frequency specifications. As I told you, if you are going to express frequency in kilohertz, megahertz, or gigahertz, you have to specify the sampling frequency. And once you specify the sampling frequency, you have to follow the Nyquist criteria and assign the frequency values of pass and stop band that satisfies the Nyquist criteria. Then coming to the magnitude specifications, you have two options available, decibels and linear. We'll go with the decibels. Now we'll design a low pass filter. The frequency response type is low pass. The design method will go with the FIR and equiripple type. And I don't want to go with the specific order. I'll go with the minimum order of the filter. And here, I don't want to go with the sampling frequency. First, I'll go with the normalized 0 to 1. As I told you, if the units are normalized 0 to 1, then the values must be between 0 and 1, the pass and stop band frequencies. So I'll go with the 0.3, and here I'll go with the 0.6. And magnitude specifications, I'll keep them as it is. Now, once you select now I'm going to design an FIR equiripple filter, low pass filter with minimum order, and the units are now I have used normalized 0 to 1 frequency specifications and magnitude specifications as decibels. Now click on design filter. Now you can see the FIR equiripple low pass filter with the pass band as 0.3 and stop band as 0.6. So this is how we can selectively design the filter using filterDesigner in Matlab. Now I will change the units to kilohertz. And now I have to give the sampling frequency. I have given as 10. Now I'll go with the pass and stop. Maximum value can be 5. I'll go with the 2 and 3. And then again click on design filter. So this is the filter with the specification of pass band as 2 and stop band as 3. So this is how the frequency specifications can be selected. And here we have selected the minimum order. So what is the minimum order of the filter? You can check here. For FIR equiripple low pass filter, the minimum order is 25. So here you can see the structure. Direct form FIR order is 25. And the filter is designed. Similarly, you can also select the other design method called IIR, Butterworth low pass filter. And once you click on IIR, you can see the density factor is the option of density factor change. And we have the option called match exactly. And you can match with the stop band or the pass band. So click on the pass band, match exactly the pass band, and again click on design filter. Now, IIR Butterworth filter with a minimum order of 16 is designed with a pass band of 2 and stop band of 3. So this is called IIR Butterworth filter. So this is how we can use the filter designer GUI to design different types of filters. And the next important point in the filter design is that you can visualize various other parameters also. So what are the other parameters we have? This is the spectrum, frequency versus magnitude. We can also have phase. We can also have group delay. We can also have impulse response. We can also see the step response. So for that, go to the top and click on the select the option. So this is a magnitude response type where we already have seen. Next is the phase response of the filter. This is the phase response. Next is the both phase and magnitude response of the filter. Then we have group delay. Then we have the phase delay. Next, we have impulse response of the filter. Next, we have step response of the filter. And also we have pole zero plot of the filter. So this is how we can use filter designer to design different types of filter and also observe various parameters such as magnitude spectrum, phase, pole zero plot, group delay, step response, impulse response of the filter. So this is the filter designer too. And so we have learned how to design a filter, how to choose the response type, design method, filter order, and frequency and magnitude specifications, and how to visualize the various parameters, that is magnitude, phase, group delay, step response of the filter, impulse response of the filter. The next one is, I just want to export this design, that is the Matlab code of this particular design. So for this, go to File, go to Generate Matlab code, or click on Filter Designer function and save the file. Matlab code for the filter design the design that we have seen in the GUI. So we have selected the sampling frequency as 10, pass band 2, stop band 3, attenuation pass 1, attenuation stop as 80, and this is the function that is for the filter design. So we have the Matlab code. So just simply save this one and run the code. And then go to command window, you can see the answer for this. Once you run the code, you can see the answer. So this is a filter structure and we have designed the filter. Now I want to use this filter design on some discrete data. So I choose X as ones of 1, 2000. Just apply. We'll call this code. So for that, first what we have to do is we have to call the function HD is equal to answer, assign, and click on enter. Now take some data, discrete data, that is X is equal to ones of 2000. And then Y, you apply the filter design. So filter of, we have taken as HD, the function is HD, so HD comma X. And then now you can plot X, that is the input, that is the data, hold on, and then plot Y. After filtering, let us see how the Y value looks. So X is ones from 1 to 2000. We have applied the filter, that this is the HD, that is a function that what we have designed. This filter design we are applying onto X. So plot X as well as hold on and plot Y. Then you can see the input as well as output, and you can see how the filter is applied onto X. So press enter. You can see the graph. So this is the filter response for X. So X we have chosen as ones from 0 to 2000. So this is a straight line, right? On which we have applied the filter. So this is how we can use the filter designer code to apply onto some data. The filter designer tool in the Matlab. I once again repeat, first we have to type filter designer in command window and click on enter. So you can choose the frequency, response type and design method and the filter order and then frequency and magnitude specifications of the filter, and we can visualize various parameters. For this, go to the top and choose the parameters. And then we can export this Matlab code for the design filter by selecting File, Generate Matlab code, and Filter Designer function. I hope you all understood how to use Filter Designer tool in Matlab.